In a typical decentralized workspace, digital collaboration quickly degenerates into entropy. Files vanish, pipelines stall, and workers are left to guess where assets belong. A decentralized digital agency producing over 200 high-stakes assets per month cannot rely on intuition. When designers, editors, and approvers never sit in the same room, individual guessing causes a folder tree to become unsearchable within weeks. Preventing this breakdown requires a deterministic architecture. In this context, determinism means removing human discretion. We replace individual preference with a system where nobody has to invent their own answer. Every digital asset has exactly one mathematically correct home on the server. That singular location is determined by 3 questions any worker can answer in under 5 seconds. What stage is the file at? What month will it be published? And whose face is in it? We are going to construct a fail-safe 5-layer digital architecture from bedrock to completion. This structure is designed specifically to mitigate human error and platform failure. Rigid folder architecture serves as a required structural defense against the inevitable chaos of decentralized human labor. The architecture begins at Layer 1, the client containment boundary. This root folder strictly isolates one client's ecosystem, preventing asset cross-contamination. Layer 2 sits immediately beneath it. The single root expands into exactly 10 distinct numbered stage folders. These top-level folders represent chronological stages of production, such as briefs, working files, and final approved, rather than arbitrary file types. The most critical operational distinction in this sequence occurs between Stage 02 and Stage 01B. Stage 02 is exclusively for working files. If you can still move a clip or edit a layer, the file lives here. Stage 01B is reserved strictly for flattened, deliverable exports pending client review. When these two states are mixed in a single folder, pipeline failure follows. The person scheduling the content cannot tell which version is the active project and which is the publishable MP4. An operating system only functions if its storage architecture mirrors the actual state of the work. Inside those stage folders, Layer 3 groups assets by a designated time variable. This time variable is always the publish month. It is never the month the asset was produced or filmed. Organizing by production month requires workers to memorize the historical timeline of the asset. Because system lookups are driven by delivery schedules, we group assets by the month the client expects to see them live. Layer 4 handles the channel mapping. Inside the month, work splits into specific terminal buckets based on the platform. The routing rule here is strictly operational. If an asset requires motion, it routes to a video folder. If it is a static image, it routes to a placement folder, like Instagram or Snapchat. Channel folders signal which specific specialist must act next. Moving files require editors, static files require designers. Finally, Layer 5 is the person variable. For brands featuring multiple individuals, raw video footage is isolated into subfolders named for each specific subject. This creates a strict structural mirroring requirement. Adding a subject to the raw footage layer mandates creating an identical character-for-character mirror folder in the video working layer. If an editor finishes a montage and the mirrored folder does not exist, they will drop the file loose in the root directory. This breaks the system logic, leaving massive source files stranded because the software cannot deduce where they belong. These 5 nested layers, client, stage, month, channel, and person, eliminate decision fatigue. The folder structure itself directs the workforce. File storage alone is insufficient. The architecture must map directly to task execution via a project management pipeline board. A common flaw in digital systems is the disagreement between task management and file storage. When board instructions contradict the folder structure, assets are filed in the wrong location. The architectural solution is to establish direct, immutable tethers connecting specific task board columns to specific drive folders. The board and the server mirror each other. Building this requires navigating a strict technical constraint of the task board's API. It cannot retroactively add sections or alter the architecture once deployed. We respond to this API limit with total upfront precision. The entire 14-section board must be deployed in a single initial payload. With the board locked in, we restrict contractor access to minimize the operational blast radius. We apply a per-task folder security role. External workers receive a link to a single isolated folder inside their ticket. They cannot browse the master directory, which confines their uploads to one location. Digital organization is achieved only when task management and file storage are perfectly synced and technically impenetrable to unauthorized structural changes. Even a perfect architecture has a hidden vulnerability inherited from the platform itself, the Google Drive ownership problem. On consumer cloud infrastructure, moving a file into a company folder does not transfer its ownership to the agency. Whoever initially uploads a file owns it. Moving the file across the server does not break that link. This creates a systemic threat. A departed contractor can remotely and permanently delete a month's worth of approved work. This is because they still technically own the files in the master system. We patch this platform flaw with the weekly ownership sweep. This sweep forces the system owner to duplicate external files. The new copy carries an internal lock, permanently severing the external ownership link. A second structural patch is the campaign exception. This forces contractors to upload all deliverables strictly into a preliminary Stage 02 working folder. This allows the system owner to natively copy the files to Stage 01B. Copying the files fixes ownership automatically within the pipeline, turning a security chore into a natural step of the approval flow. A professional digital operating system must actively patch the hard-coded constraints of the platforms it runs on. Zoom out and the entire ecosystem is visible. The 5-layer drive architecture, the task pipeline, and the local PC access layer function as a single source of truth. Maintaining this truth requires actively fighting silent drift, the tendency for workers to slowly invent new naming conventions or build parallel, unapproved folders. Preventing this drift requires microscopic file hygiene. Even a trailing underscore on a folder ID will truncate a URL and break a sharing link. The system demands exact precision. When an operational anomaly occurs, like a unique ad campaign, the system uses a strict protocol. If the system must bend, we document it explicitly as an exception. A rule followed only half the time destroys the illusion of control. It signals to the workforce that the operating system cannot be trusted, allowing entropy to return. Structural integrity in a digital workflow is binary. A system either works completely or it is already broken.